Alright, hello. So I'll be going over the steps on how to calculate the empirical formula of various percentages. So I'm just going to start off with the steps on how to find empirical formula. So I'm just going to write this to the side. So it's like a little saying, poem, or whatever you want to call it, to remember the steps. So first we've got percent to mass, mass to mole, divide by small, round till whole. So these are the 4 steps to calculate. So it's a good way to kind of chant it in your head once you do the quiz or test, so you remember the steps on how to do it. So again, empirical formula, what that is, it's the simplest, my simplified definition of empirical is the simplified version, simplified compound. Let's just do that. So if you remember last semester, I'll put this aside. If you remember last semester when we did ionic compounds, when we did okay, we have SN and O. SN has a +4, oxygen has a -2, and when we crisscross, we end up with SN2O4, and then we can see this can be simplified to SNO2, so the simplified subscripts. This is empirical. Okay, this is molecular, which we'll get into that another video, but this is empirical, and instead of be given charges and whatnot, we'll just be given percentages of mass to figure out our subscripts. Okay, so here is an example of an empirical formula example. So let me just pull one up. So let's say we have 13.5% calcium, 10.8% of oxygen, and 0.675% of hydrogen. So we have these percentages. And when it comes to empirical formula calculations, just to make things easier, because life is already hard, we're going to assume everything's out of 100 grams. Always assume out of 100. So that way when we do 13.5% out of 100, that is 13.5 grams. So we are doing the first step right now. So 13.5% is now 13.5 grams of calcium. 10.8%, 10.8 grams. And then 0.675 grams of hydrogen. So that is our first step. All we're doing is just simply changing the symbol. Now, mass to mole. How do we do this step? We simply just divide by the molar mass. So MM, molar mass. So where do we find the molar mass again? From the periodic table. So calcium, we divide our number by 40.078. We should get a number. We'll get back to this. We're just going to set it all up. For oxygen, we divide it by 15.999. Then hydrogen, divided by 1.008. Again, don't round. Just write it as you see it, because if you round, you're rounding too early, and that affects the entire answer. Alright, so when we plug this in, divide. So 13.5 divided by 40.078. So with these simple calculations, you can use your phone. I don't recommend it because, first of all, you can't use it on the quiz or test. You have to use a calculator. Second, your phone tends to round too much and rounds too early when you're doing these calculations. So I recommend a nice calculator to give you the accurate answer. So this first one, and we're going to round to the thousandths place, 3 decimal places. So in this case, it would be 0.337. Next one, 10.8 divided by 15.999. So I'll do 0.675. And then 0.675 divided by 1.008. So this would be 0.669. That would round to 0.670. All right. So that is the second step here. We just divided by their molar masses. Divide by small. So what I mean by this, so technically it's divide by smallest out of these numbers, but I just put divide by small because it just ruins the vibe of the poem. But anyways, with these 3 numbers, the smallest out of these 3 is 0.337. So we're going to divide all of these numbers by 0.337. So divide by 0.337 because we're trying to get subscripts here. Divide by 0.337. Divide by 0.337. And once we get the answer, we're going to round to the nearest whole number. All right, so obviously when you divide it by itself, it's 1. 0.675 divided by 0.337. Notice you have this decimal, but it's 2.00, yada, yada, yada. It's just 2, nearest whole number. Okay. The last one is the same thing. So when you divide that, you get 1.988. That's pretty darn close to 2. It's 2. So these numbers, these whole numbers tells you I have 1 calcium, 1 oxygen, or sorry, 2 oxygens, 2 hydrogens. Now you build the compounds. So Ca, you don't have to write the 1, O2, H2. This is your empirical formula. Or if you want to be extra and write it the real correct way, which it doesn't matter to me, you can do Ca, put OH in parentheses, 2, since it makes both of these 2. Alright, so if you want to do this to be professional, you can do that, or this is totally fine too. Ca, O2, H2. So that is pretty much empirical formula. I'm going to give you another example, and you're going to try to do this by yourself. Alright, let me try to make one up out of my mind here. Let's say I give you 53.5% copper and 12.7% sulfur and 2.7% oxygen. Let's try this out. Okay, so pause the video, and once you solve for this, again, do the exact same work here. This is what I'm expecting, and I'm sure the other teachers as well is expecting this type of work on the quiz and the test, of course. So make sure you do all this. This may be tempting, like, oh, I can just do all this in the calculator and I'll get my answer. Something can go wrong when punching everything in at once. So write everything down to get your answer so you get full credit. So follow these steps, do this work. So try this example, pause this video, and check your work once you are done. Alright, you should be able to get this empirical formula for copper, sulfur, and oxygen. Yes, some of these may look weird, and that's okay, as long as it's simplified. For in this situation, when you divided 0.396 divided by 0.169, I got on my calculator 2.34. That rounds down to 2. Alright, and then everything else should be rounded pretty nicely. Alright, so I'll give you one more. Try it out. And you should be pretty solid once you get this right. Let's do something simple. I am trying to figure something. Let's do something weird but simple. Let's see if this works. I'm trying to do simple percentages. 70, 15, 15. It should be out of 100. If it's not out of 100, it's fine. Just always assume out of 100 grams. Alright, so we've got percent to mass, 100 grams Na, 15 grams P, 15 grams O. Divide each of these by its molar masses from the periodic table. Alright, I hope you're with me. I hope you're working with me, by the way. But yeah, just divide each of these by its molar masses. And I know the smallest number is 0.484. Divide each of these by 0.484. Round to the nearest whole number. Let's see what we get. Alright, got 6 for Na, 1 for P, 2 for O. So, put it all together. Na6, PO2. Looks weird, but it is what it is. There it is, the empirical formula. And that's pretty much it. There's nothing more to it. Kind of tedious, but that's pretty much the steps on how to do it. I hope this helps. But yeah. Have a great day.